Okay, so now we are going to take forward our discussion on the types of matrices, and the next category of matrix which we are going to discuss is the idempotent matrix. Okay, so a matrix, let's say a matrix A. Okay, a matrix A. It is called as idempotent if the square of the matrix, okay, the square of this matrix gives us the same matrix again. Okay, if the square of the matrix A gives us the same matrix A again, then it is said to be an idempotent matrix. Okay, now an example of such a matrix is this second order unity matrix. We can check that. Okay, suppose we square this matrix. Okay, this is an example of idempotent matrix. Now let us just confirm that. Let us perform the square of this matrix. A square 1 0 0 cross 1, again 1 0 0 1. Now these two matrices can be multiplied because the number of columns of the second matrix is equal to the number of rows of the first matrix. This is the important condition to be satisfied for the two matrices to be multiplied. The number of columns of the first matrix should be equal to the number of rows of the first matrix. So here both are square matrices of order 2, so there is no problem about that, they are equal. Now let us perform the multiplication. See, the multiplication happens first 1 cross the first row of the first matrix with the first column of the second matrix. So it will be 1 into 1 plus 0 into 0. Next will be the first row with the second column. It will be 1 into 0 plus 0 into 1. Okay, this multiplication will be the second row with the first column. It will be 0 into 1 plus 1 into 0, and this will be 0 into 0 plus 1 into 1. The resultant will be again a 2 cross 2 matrix. So the result will be 1 plus 0, which is 1. This again 0 plus 0, which is 0. Here also 0 plus 0, 0, and here 0 plus 1, which is 1. Okay, so we got the same matrix again. Okay, which is also a unity matrix. This is also a unity matrix, a second order unity matrix. So the multiplication of this matrix again with the same matrix got us the matrix back again. So it is an idempotent matrix. Now, so the next type of matrix which we are going to discuss is the involuntary matrix. Okay, now a matrix, let's say A, okay, a matrix A is said to be involuntary if the square of that matrix, okay, the result of the square of that matrix is the unity matrix or the identity matrix. Okay, if the square of a matrix gives us identity or unit matrix, the matrix is said to be involuntary. This is the condition for a matrix A to be involuntary. Okay, then matrix A is involuntary. Now an example of such a matrix is this equal to minus 5 minus 8 0 3 5 0 1 2 and minus 1. It is an involuntary matrix. Okay, so let us check that whether the square of this matrix gives us identity or unit matrix or not. Okay, so let us write the matrix here. It is minus 5 minus 8 0 3 5 0 1 2 minus 1. Okay, now we'll multiply the matrix with itself. Okay, the square of the matrix. Minus 5 minus 8 0 3 5 0 1 2 minus 1. So both are square matrices of order 3. So we can easily multiply them, as the number of columns of the first matrix is equal to the number of rows of the second matrix. This is the important condition for matrix multiplication. So now let us perform matrix multiplication. First row with first column, then first row with second column, then with third column, and so on. Then second row with first, second, third row with first column and second column and third column. That way we will proceed. So the result will be minus 5 into minus 5 plus 8 into 3, sorry, minus 8 into 3 plus 0 into 1. Similarly, is 5 into minus 8 plus minus 8 into 5 and plus 0 into 2. Next, minus 5 into 0 plus minus 8 into 0 plus 0 into minus 1. Okay, next, second row with first, second and third column and respectively, it will be 3 into minus 5 plus 5 into 3 plus 0 into 1, 3 into minus 8 plus 5 into 5 plus 0 into 2 is 3 into 0 plus 5 into 0 plus 0 into minus 1, again 1 into minus 5 plus 2 into 3 plus minus 1 into 1, again 1 into minus 8 plus 2 into 5 plus minus 1 to 2, again 1 into 0 plus 2 into 0 minus 1 into this one. Okay, so this is the resultant matrix. Now let us see what the individual elements are. Okay, this is 25 minus 24 plus 0, 25 minus 24 plus 0. This is 40 minus 40 plus 0, and this is 0 plus 0 plus 0. Next, this one is minus 15 plus 15 plus 0. This is minus 24 plus 25 plus 0, and this is 0 plus 0 plus 0. Okay, this one is minus 5 plus 6 minus 1. This is minus 8 plus 10 minus 2, and this is 0 plus 0 plus 1. So the resultant matrix here is 25 minus 24. This is 1. Okay, I'm writing the result here. It is 1, 0. This is 40 minus 40 plus 0 is 0, and this 0 plus 0 plus 0 is 0. In the second row, this minus 15 plus 15 plus 0, which is 0. Then there's minus 24 plus 25 plus 0, which is 1. And this is 0 plus 0 plus 0, which is 0. In the third row, it is minus 5 plus 6 minus 1, which is 0. Then there's minus 8 plus 10 minus 2, which is 0. And this is 0 plus 0 plus 1, which is 1. So we got the third order unity matrix or identity matrix. Okay, the result of this matrix multiplication is the unity matrix or identity matrix. So it is an involuntary matrix. Okay, as the square of the matrix got us the identity or the unit matrix. Okay, so this is an involuntary matrix. It has been proved.